Regular expressions define languages. So let's start with a couple of examples. Let's define a language of things cows say. So we know that a cow says moo, but maybe a cow might say it a little bit longer. They might say moo. Okay? So that's a regular expression. What we've done is taken one language, which is moo, and unioned it with another language, which is moo. And so we now have two lexemes in the language. Moo with 2 and moo with 3 O's. Okay, and we can simplify that. We could say it's actually M-O-O with an optional last O. So remember that the question mark operator means 0 or 1, and that gives the same language. In fact, let's write the language here. So we have the language is the set moo and moo. And here, the language is the same thing. We have moo, or we have that with the optional O at the end. Okay, another language might be, for a cow, M-O plus, which would be M-O, remember plus means one or more, mo, moo, 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 and so on. Okay, let's look at C, a language we might call C minus minus. This language can be super simple. We are going to have, let's say we have a for keyword, we have an if keyword, and we have identifiers, which are characters, strings of characters. So how would we define this language? Well, we start with the language for. We union that with the language if. We union that with the language of identifiers, which would be, let's just say for simplicity, only lowercase letters, one or more. And that would be our language. Now, we have a number of languages here. We have this is a language. It's a language of one word or one lexeme, a language here. And then we have a language here, and we're unioning those languages together. All right, what about matched parentheses? Let's see if we can come up with a regular expression for that. So we have one parenthesis and the second parenthesis. And let's just say they're nested matched. So that's one word in the language. We have this as another word in the language. We have this. Now, that right there would not be a word because the parentheses aren't matched, so we have that, and so on. So can we come up with a regular expression that does that? Well, we might say, well, let's do left paren star, which is clean closure, which means 0 or more, and right paren star. Well, the problem there is that that could be 2 left parens and 0 right parens, and they're not matched. And so it turns out that this language is not regular. It's not a regular set, which means we can't express it with a regular expression. RE is a shortcut for regular expression. Okay, now let's look at this figure in the book, which talks about the different laws we can use when combining languages. So let's look at the first one, that union is commutative. And we're going to use this as an example, A unioned with B, A question mark. So first of all, so it's A unioned with B, A question mark. What is the language A? Well, it's the language with A in it. And we're going to union that with what the language be a question mark. So that's 0 or 1 A's. So we have B with 0 A's. Oops. And we have B with 1A. Okay, so those are two languages. We're going to union them together to come up with A, B, and BA. And that's our new language. Okay, now the law says that is commutative. So this should be, this right here should be equivalent to BA question mark unioned with A. Is that true? Well, we can just look over here and we just swap those and we see that what we get is B, BA, and A, which is a set that's equivalent to this set. So these two are equivalent and that is shown to be true. Okay, so let's do the next one. Union is associative. So we have A union with BA question mark or C, union with C. So first of all, what's this language here? So we have A, we know that, and we have B, A, B, and C. Because this language is just the set with C in it. This language is the set with B and BA in it, just like we did here. B and BA. And those union together gives us that set. Union everything together, we're going to get A, BA, B, and C. And we can see that it doesn't matter whether we union those together first or whether we union these together first, which is what this is saying here. We can union either one together. All right, concatenation. So we're going to look at this regular expression here. We have A, B, A question mark, C. Now, notice that I didn't put these union operators in. We're just concatenating them together. So first of all, let's look at these two languages concatenated. So B, A question mark concatenated with C. What does that mean? It means we have B with 1A concatenated with C. And we have B with 0 A's concatenated with C. And to the front of that, we're going to concatenate A, which gives us A, B, A, C, and A, B, C. Right, we're going to concatenate A with BAC, and we're going to concatenate A with BC. And the associativity of the concatenation operator just means that we can concatenate A to BA question mark first, and then tack C on to the end. Okay, and the last one we want to talk about is concatenation distributes. So let's look at this one here. So we have A concatenated with BA question mark or C. So what this gives us is A concatenated with B, BA, or C. And that's going to give us AB, ABA, and AC. Okay, so now can we distribute that to be A concatenated with BA question mark or A concatenated with C? So let's see if we get the same thing. We have A concatenated with B and 0 A's, A concatenated with B and 1A, and A concatenated, unioned with A concatenated with C. And is that the same thing as we got here? And the answer is yes. So we've shown that concatenation distributes over, well, we've shown an example of concatenation distributing over the union operator. Okay, these three are pretty self-explanatory. We take any regular expression, we put epsilon under the beginning or end, and we're just going to get the regular expression out because E is the empty string. And similarly, If we have a regular expression with clean closure, which means 0 or more, then we are guaranteed to be able to have, we're going to guaranteed to have the epsilon string in the language. Because if we have 0 r's, we're going to have 1 that is empty. And the closure operator is idempotent, or idempotent. And basically what that means is we can have as many stars as we want, and it makes no difference. It's the same as 1 star.